Good day, viewers all over the world. You are welcome to Trident online class. Today we want to consider differentials. But before we do that, we want to treat about two questions before we treat that. Like the question that we have on the board. The question that we have on the board, where we are to show that u of x comma y, x comma t is equal to 1/2 square root of pi t exponential minus x squared all over 4t. Define for t greater than 0. Satisfy this equation. This is the equation. We want to show that for u defined as what we have on the board. We want to show that u satisfy this equation. This is the equation that u all over di t is equal to di square u all over di x squared. That is, this is u. U is defined as what we have on the board. U is defined as this. So what we are asked to do is that we want to find di u di t. Then we go ahead and find di u di x. Then we find the second derivative, di square u di x squared. If at the end of the day we are able to show that the value that we got here, di u di t, same thing as di square u all over di x squared, then we have been able to satisfy what we are asked to find. So now let's go. What is u? U of x comma t is given as what? 1/2 pi. Of course, this is square root of pi. The square root of t is same thing as square root of t is same thing as t raised by half. So I want to rewrite this as, then if t, this we are going to have t raised by half here. If I don't want to include this square root here, because we want to find di u di t, so I want t to be separated. 1 / x exponential x squared 1/4 t. The t can come up here. This t raised to power 1. If you should bring t up here, it will be t raised to power -1. It's still the same thing. What I define here and what I have here is the same thing. It's just a matter of mathematics. So it's the same thing, right? Then, what do we have there? Please, let's note the value of u and what we are asked to show, because I will need to do some cleaning as we proceed. I will need to clean it and we'll continue from there. So, what do we now have? If I take the partial derivative, di u all over di t, that is, if I differentiate u partially with respect to t, what am I going to get? Please, let's look up. Of course, we are going to apply product rule here because we have t here. Then we also have t as the power of the exponent. So if I pick this first one, I will differentiate the exponential. Then I'll go back to pick the exponential and differentiate the first one. So whichever way. So what do we do here? Or I can bring this t down, t raised to power half. I can bring it up to be equal to t raised to power. No, this is 1. So this will just be t raised to power -half. Law of indices. T raised to power half there. I can take it up to have something like of this nature. So let me differentiate. We are going to differentiate using. I will differentiate this first one now. I will pick this. I will come back and pick this to differentiate this and pick this. That is the product rule. So if I differentiate t raised to power half, no, we are differentiating u with respect to t. Every other t will be assumed to be constant. We only differentiate t. T raised to power half. The derivative of this will be -half. If I differentiate this t, then I'll subtract 1 from it. T raised to power -3 all over 2 square root of pi. Then I'll pick this exponential minus. I can just write it x squared all over 4t is the same thing as this. Okay, plus I've differentiated this. I pick this. I will not. I differentiated this. I pick this. I will not differentiate this and pick this. So if I differentiate what I have here, the derivative of exponential simply means differentiate what you have there. Use it to multiply. So if I differentiate what I have here with respect to t, I'm going to get, there's 1 minus here. If I differentiate this now, that will be minus 1, then I will have plus. So I'm going to have, what I'm going to have there will be s squared t raised to power minus 2 all over 4. That's the derivative of this. Then I'll pick this, multiply by what I have here, which is t raised to power minus half all over 2 square root of pi. I will now pick exponential minus s squared all over 40. This is what I'm going to get. If I do that, that's what I'm going to get there. That's what I'm going to get. Please, we are going to take into cognizance it's partial derivative. But when we pick this one, we differentiate this. We come back and pick this, we differentiate this, product rule. Then I can rewrite what I have on the board. So finally, the value of di u all over di t will now be, we can write everything neatly. 2 times 2 will be 4. So I'm going to get minus 1 all over 4 square root of pi. Then this is t raised to power minus 3 all over 2 exponential minus s squared all over 40. Okay, plus, when I write that one neatly, I can write what I have here neatly. 4 times 2 will be 8. 4 times 2 will be 8. Then I will have 1 all over 8 square root of pi. Then t raised to power minus 2 times t raised to power half. Law of indices. We add the two together. That will be the same thing as t raised to power minus 5 all over 2 exponential minus s squared all over 40. This is what we are going to get. So let's take note. Let's take note of the value of di u di t. So we have gotten the value of di u di t. So let's take note. We have gotten the value of di u di t. The value of di u di t is this. Let's note it somewhere. This is the value of di u di t. So we now go ahead. We have gotten the value of di u di t. Okay. So we have gotten the value. We now go ahead and find the value of di square u all over di h squared. So we have gotten the value of this. So we have gotten the value of this. So now let's go. We now want to find the value of di u di x. This is the first one. When we find the value of di u di x, we now go ahead and find the second derivative, di square u all over di x squared. So if the value of di square u all over di x squared is same thing as what we have gotten there, then we have been able to show that the equation is equal. So now let's go ahead and find di square di u all over di x. This is u. Now we are differentiating u with respect to x. We are differentiating u with respect to x. So what do we do there? So this 1 over 2 pi x pi t does not have anything in form of x. So I will only write that. I can write it as t raised to power minus half all over 2 pi. 2 square root of pi. The same thing, because square root of t is t raised to power half. If you take t raised to power half to the numerator, it's going to attract a negative sign. So this is what we have. Then multiply by, if I differentiate what I have here at the numerator with respect to x, I'm going to get, if I differentiate x squared, that will be 2x. So I will have minus 2x, okay, minus 2x all over 40. And of course, I can take t to the numerator. 40 t, this is t raised to power 1. If I take it to the numerator, I'm going to have t to be t raised to power minus 1. It's still the same thing. I only apply the law of indices. Then I will write what I have here. E raised to power minus s squared all over 40. That's what we are going to get. So please, let's follow. Let us follow the step. So if I do this, I'm going to get 2 can cancel 2. I'll get minus 1 all over 4 square root of pi all over t raised to power half times t raised to power minus 1. That's t raised to power, we have it to be minus 1, right? T raised to power minus 3 all over 2. That's what I'm going to get. Exponential minus s squared all over 40. This is the value of di u di x. So we have gotten the value of di u di x, but in what we are asked to show, it is di square u all over di x squared. So I'm going to differentiate di u di x the second time. I'm going to differentiate the u, the x the second time. So once I get the value of the u, the square u, all over the x squared, if it is the same thing as this value, then we can generalize and say that what we have is equal. So let me start with this. Let me just find a way of writing the value here. I want to differentiate the u, the x the second time. So if I do that, let's see. From here now, I want to differentiate this second time. The square u all over the x squared. So I want to differentiate this the second time and see if we are going to get the same answer. So if we are able to get the same answer, then it shows us we have been able to prove the heat equation that we are asked to show. Okay, so I will say the square u all over the x squared is equal to, we want to differentiate this the second time, differentiate to x. Of course, if we look at what we have on the board, we realize that no, there is x here. This one has x. So there is x here. There's x here. It has x here. There's one x here. So if I want to differentiate the second time, I'll first differentiate this. I'll pick this one. Then I'll go back and pick the second one. And just, I want to apply the knowledge of product rule. That's what I want to do there. I want to apply the knowledge of product rule. So if I do that, I will differentiate this one. It has x. This component has x here. And if I differentiate this now, if I differentiate this, it's only x that will go. Every other thing will retain its value. Let's look at this. It's only x that will go. Every other thing will retain its value. So if I differentiate this now, I'm going to get minus 1 all over 4 square root of pi. Then t raised power minus 3 all over 2. Okay. When I differentiate this, I'll pick this exponential minus s squared all over 4t. Okay. Plus, I will now differentiate this. I will pick this. So what do I have here? I've done the first one. I will now differentiate this other one. You know, I differentiated this. I pick this. I will now differentiate this. I'll pick. Let me first pick this. This will be minus x all over 4 pi square root c raised by minus 3 all over 2 multiplied by, if I differentiate what I have here with respect to x now, it will be minus, it's going to give us minus 2x all over 40, okay, exponential minus s squared all over 4x, all over 40. This is what we are going to get, okay. So I can rewrite that neatly. So this is what we are going to get. I'm trying to adjust it so I can rewrite this neatly. So let's look at what we have here now. Minus can cancel minus. Minus times minus is plus. So I will remove this. 2 here 1, 2 here is 2. Okay, 2 here is 2. Okay, then I'm going to have x here. I will have x there. So I'm going to have x there. So what do we now do? What do we do? I want to rewrite it. I want to rewrite the value neatly. Somewhere. So if I rewrite the value neatly, let's rewrite the value neatly somewhere and see if you are going to get the same thing. This is x squared. This is x squared. So I want to rewrite the value neatly. So I want to look for a place to rewrite the value neatly. So if I rewrite the value neatly, so let me just rewrite the value somewhere there. So from there now, the square u all over the x squared will now be equal to minus 1 all over 4 pi square root of pi x t raised by minus 3 all over 2 exponential minus x squared all over 40. Then here we now have plus x squared 4 raised by square root of pi c raised by minus 3 all over 2 exponential minus x squared all over 40. That's what you are going to get. Then if you check this, the u, the t very well, when we pick the first one, that you that see very well. When we pick the first one, when we differentiate the second one, we have made a mistake here. There will be S squared here. There will be S squared here. If we check when we differentiate the second one, there will be S squared here. So please check. Let's you go ahead and differentiate the exponential. You pick the first one. So when we look at what you have done before, there will be S squared here. So if you look at these two, what you have done here, at the end of the day, you realize that di u all over t is same thing as di square u all over di s squared. So please let's check. Let's go over it and check very well. So since we have been able to show this, it shows that that equation, it shows that the equation is satisfied, and that's what we are asked to do. It shows that the equation is satisfied, and that's what we are asked to do. So please let's take note of this question very well. It's just a matter of when we apply product rule. If you have to differentiate, this is a partial derivative. So if you have to, when you see something like that is a partial derivative. So it depends on what we are asked to do. For instance, when we are asked to differentiate the u with respect to t, we assume that exponential, that x here is constant. Then when we are asked to differentiate u with respect to x, we assume that t is constant. The normal way that we differentiate partially. First class. So when you go through, you just know differentiate partially u partially with t. Let's try and correct where we're going to get this x squared. It's there. There was an omission when I was trying to write this. So please go over it. So at the end of the day, the value of the square u over the t is same thing as the square u over the s squared. So we have been able to show that that equation u s of t satisfies its equation. So that's what we are asked to do. So I want to clean this now so that we can take another. We can take another example. So I would love to clean this now. I want to clean this so that I can introduce differentials. So let me clean this. Then I will introduce differentials. So just go through the notes, go through everything religiously. Then you will understand what we have done. You will understand what we have done. So let me introduce differentials. 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 I want to introduce the differentials. So if z is a function of x and y, okay? If z is a function of x and y, then the z will be fx the x plus fy the y. That is what we're trying to say, is that the z will be partial derivative of f with respect to x dx, then plus partial derivative of f with respect to y the y. So this is what we are trying, we want to establish. This is what we want to establish. And that's that about differentials. So I'll just give one example. Let's give one or two examples in order to be able to establish these differentials. So let's say example, you can call this example 2, since we have considered one example before. When we say compute the differentials for z is equal to e raised power s squared plus y squared tan 2x. So that's the question. We want to compute the differentials for the question that we have on the board. So what do we do here? Of course, z, in this case now, this z is a function of x and y. You realize that there are two variables here, x and y. Whatever you see here is a function of x and y. So z is a function of x and y. Then how do we compute the differentials? Of course, the z, which is the differential, will be partial derivative of f with respect to x dx plus partial derivative of f with respect to y by y. And that's all that we want to do. So that is what we want to do. So that's what we want to do here. So now let's just write. That is what we are asked to do, and that's what we are about to do now. So what are we going to get? Of course, there is z. We have to compute the differentials for this. Will be partial derivative of f with respect to x, the x, plus partial derivative of f with respect to y, the y. That's what we are going to get. So if that is the case, then we can go ahead. We can go ahead and solve the problem. So from here we are going to have. So we want to differentiate this now with respect to x partially. If we differentiate this with respect to x, of course this one has x. There are two functions here: exponential function and trigonometric function. Exponential trigonometric function. So when we pick this first one, we differentiate this. We come back and differentiate this and pick this. When we want to take the f, the z, that is, if I pick this first one with respect to x, I'm going to have 2x. I will have 2x exponential x squared plus y squared. I've differentiated this. I'll pick this tan 2x. Then plus, I will not differentiate this. I pick this. The differentiation of tan is x squared. When you differentiate tan, it's x squared. But here we have 2x. So when we use function of a function, at the end of the day, we are going to have 2. We are going to have 2 exponential x squared plus y squared x squared 2x. That's what we are going to get. So everything that we have here is the f, the x, the x. Plus, so we have done one part. We have done one part. So we have done one part. Plus, then we find the f, the x, and the f, the y. So we want to also differentiate this function with respect to y. Of course, this tan does not have y. Tan does not have y. So we don't need to bother ourselves. Tan does not have y. We don't need to bother ourselves. We only differentiate y here. When I differentiate y here, I'm going to get 2. I'm going to get 2y exponential x squared plus y squared tan 2x. That's what we are going to get. So the differentials that we have to compute, is what we have done on the board. So I can just go ahead and rewrite this. So that the z, which is differential, will now be 2 is common. 2 is common. Exponential x squared plus y squared is also common. 2 is common. Exponential x squared plus y squared is also common. So we might start to leave our answer in this form, or we can just say we can bring up x squared plus y squared into brackets. If we bring this up, we are going to have x tan 2x, then plus sec squared 2x dx. So we can do that. Okay, dx plus if I assume that I brought out everything there, okay, I can have plus y tan 2x dy. Okay, so I can write it in this form and stop at this point. I can write it at this point. Okay, so if you like, you might try to stop at this point, but if you want to collect the like time, if you want to bring out something that is common, 2 exponential x squared plus y squared is common, then use curly bracket. That's the bigger bracket. Take care of the one with the x, you take care of the one with the y. It's the same thing. Or if you don't want to stress yourself, you can just stop at this point. It's still the same answer. So that's how to find the differentials. That's how to find the differentials. So I will want to advise that we should go through all the process that we have done in this class. Then at the end of the day, there won't be any course for allowed. Just let's go through the process. So I would love to stop here because of our time. We are going to continue from there some other time. Thank you.